Yes, we are live now. So, hey folks, this is me, Vishwas, and I'm the host of this Bell Piper show. Today happens to be the 8th year initial release anniversary of Terraform from Ashikop. That journey was a new beginning. That really marked the history of what accessibility in the world of DevOps was all about. So everybody thought about implementing technology in a different ways, and there were new ways in which this technology was actually booming up. So I think I'm glad that today we are hosting a show on Terraform, and we are celebrating its anniversary by educating somebody on Terraform. And thank you so much, folks, for joining in. Means a lot. And if you are tuning in, and if you have a lot of things to share, do drop it down in the comment section below so that we can connect with you as soon as possible. And also, there is a lot of things to be learned and unlearned over this course of time. So I welcome Samik sir for being on the show, educating us with respect to Terraform. Thank you so much, sir.
Hey, thank you, Vishwash. Thank you for having me in. And I'd like to thank everyone who took their time on Sunday morning to join this webinar. Right. So yeah, mm, basically, to start with today, right? As Vishwash mentioned, it's been more than 8 years now. Terraform is with us, and then we are trying to learn. And in today's session, I would, like to demystify some of the myths, what we can do, what we cannot do. I'd not say cannot do, but it's just the other way we can do in things in Terraform, and then why actually we need a platform like Terraform, right? And in terms of DevOps. So just think of a scenario. Many people even new in the IT and infrastructure world, right? So think of a scenario. I mean, or if I've heard about stories, there are places around 1990s or 2000, to develop and host an application. What supposed to happen is you just basically buy a full new infrastructure, right? And then put your code, and then irrespective of application go hit or flop, you have to be there. You have to keep this for at least 5 years because you paid money for that, right? That was a huge, huge thing to set up. Even that actually stopped lot of people to have their own ideas into production, because that was like the cost kills you at the first place, right? Now, after that, when and DevOps came in, right, or basically I'd say the cloud infrastructure came in, right? So cloud came up with a user interface wherein you don't need to go of the hassle of ordering your servers and buying your things like that, and you just try to do something like and do some button click in the user interface. So if you talk about the major cloud vendors, right, AWS, Azure, or GCP, right, wherever you go, the moment they got released, what happened is you get to see a UI. And whenever you get to see a UI, you just do some checks, fill up some check boxes, and then click some buttons, and then you have your server up. I would say not server. So if you talk about an application, it's like a bunch of resources. So a server, a web application hosted in the server, the network piece, and the load balancer, things like that. So you get a UI. So that was the first privilege for an application developer to host their application into cloud and make it accessible. So that was the first thing. Right now, after that, what happened is even that was not enough. So if you look at the biggest vendors, Amazon and things like that, they have a sale day, and then at that date, like, they really need to have a great infrastructure where and but they don't need it for the rest of the year. So the scalability of the concept of scalability came in, and then there are also cases, right? It's not that you'll be able to see things like I mean, you'll not be able to deploy the servers right away, and then that will. I can see it's not audible. Is it okay? Bishwash, you're not audible, or you made me mute.
I'm in mute. I'm in mute.
Okay,
Yeah.
okay. Am I audible, guys? I think I got a comment.
You are audible.
Wonderful.
Hey,
Okay, thank you.
you are audible.
Okay, thank you. So basically, what happens is, you have your production setup, right? But that doesn't help you to test and build your code. So if you really need to have a DevOps, or I would say application lifecycle, right? You were supposed to have an environment of development. You have supposed to have an environment of staging, and then you're supposed to have an environment of production. But in cloud, it was easy. But it was easy. You can build your dev. You can build your kind of you can build your pre-prod or test environment, and you can build your prod environment, but it was really difficult to manage them all together, right? The piece which was missing is like, I have my code tested in dev, but how do I make sure it goes to the pre-prod or the testing environment or the prod? All right. And that's where the catch is, right? And then the way DevOps came in and the GitOps concept is recently coming in, right? What it ensures, right? Let's say you're running a simple application in cloud, let's say AWS or Azure or GCP, wherever you choose to be. Now, once we do that, we also need to make sure that the infrastructure we are having in dev, right? That same thing has to go in the kind of same configuration has to go in the testing environment and in the production environment in indefinitely in a scaled up way, right? Now that's where the infrastructure become more and more sensitive, because in our previous cases, we devs are kind of given a box where you develop all application and write code using Visual Studio and any other, maybe Eclipse and things like that, and test it, and then give a package to the administrator, he deploys it. But now that become a lot more easier with the cloud infrastructure. But still, the piece that was missing is how do you make sure that all the environments are in sync. For example, right, let's say you need to add a subnet in all your environments, right? So there should be a way to do that, right? And that's where this infrastructure as a code kicked in, which made the way that let's say you have the way you code your application, right? Let's say you have an instance, you have an instance. Let's say you have an employee application, and then in that application you have a class instance, things like that. The same thing was repeated in the infrastructure, so you can actually define your infrastructure in code, right? Now that was the first solution to the problem. And then when you can define the infrastructure as a code, what happens is you can see the infrastructure. Till the time you're only able to visualize, okay, I have 5 servers or I have 50 servers, but you cannot visualize that. In here you can visualize what exactly the servers are, and even the detailed one, like what operating system my server is having, how much of RAM my server is having, or what is the tier of things our applications and servers are having.
Yeah.
Now having yeah, so that was, I would say, the change in scenario with infrastructure as a code, right?
Yeah, like today happens to be the 8th year anniversary. So now Terraform has changed from every version to version. Like every new releases bought some new packages. So how do you think is the world today applying for the scalability today? And with respect to infrastructure provisioning, with respect to managing it, and also in terms of, yeah, 8 years plus 1 month, yeah, like whatever it is, like it's a great amount of time span that this technology has influenced. So how do you feel that today this entire scalability and everything is thought about today with respect to the automation that it gave, with respect to the DevOps aspect that it's covered over a course of time?
So basically, let's pick up the same story. Let's say we have an application, and then now we're exposed to a cloud, environment where you have a user interface, where you can create our servers and things like that. But and again, they are also extending this in terms of APIs, so you can have APIs, command line interfaces where you can actually, write some code and then try to run a PowerShell command, or maybe use some CLI tools to provision infrastructure. But beyond that, again, there was a need of templatizing the infrastructure so that it can be repeated, one thing. Second thing, it can be packaged, and it also can be maintained to make sure that you exactly know what your environment looks like, right? And you can scale up, right? So for example, just to give you a little bit detail around Terraform, and why Terraform. So Terraform is so mature that you just tell Terraform, I need 5 servers, 5 applications, and XYZ, right? You don't need to tell them how it's going to do it. It internally has that intelligence to figure it out. Like, it plans it, and you deploy 5 servers. The way you define the dependencies, it figures out I have to deploy server A first, then server B, then server C, and then it basically spins it up. And then in the console it happens, and all the things happens on cloud. So there's no native dependency. So it's not like we cannot say as a developer it works in my machine and doesn't work in your machine, right? So that statement is not valid anymore. I mean, so that was the thing. And then with this, right? So Terraform has also an option of having your environment separated. So basically, let's say if you have a dev environment, right, where you want to have only two servers, and your testing environment also need to have only two servers, but whereas your production needs like five or six servers because they are exposed to more than 1,000 people maybe. All right. So that's where you know that's where it is like we are good with the Terraform thing. And then I have a plan to show you a little bit of demo. May not be I may not be able to deploy that application, but I would like to explain in terms of coding how easy it is to write a code, and then how what
Yeah.
happens behind the scene. Yeah.
I think there are many other professionals coming out with. I think we are calling a lot of Pulumi experts as well. We are also calling different people from different parts of the world. I think there is going to be a lot of challenges that we will be facing. There's going to be a lot of talks that we'll be having. I think, sure, folks, let's get in. Let's get in with an hands-on demo so that we get to learn something new. Sure, sir. I'll share your
Yep.
screen.
Thank you. So basically, if you look at my screen, right, this is and people who don't see what I'm using VS Code. That's a free downloadable tool by Microsoft. You can just download the installer, and irrespective of Windows, your Mac, you have Windows, you can actually install this. All right. Now, what is Terraform? Even before we go to Terraform, right? What we should understand is how Terraform basically works, right? So if you look at my folder structure, so there's nothing like you have to define DLL and things like that. It's like you have to install Terraform natively, and there are a few commands which you just need to remember that, and that's all talks about the workflow. So the first thing is I'd say, and I'm straight away jumping to the code, but I'll just definitely love to kind of refer back. So I'd say Terraform init. So what happens if you talk about any of the initialization by default, right? Initialization makes sure that you are setting up your environment, and then you're telling Terraform, I'm initializing this environment for me. Now init basically, and also whenever you are doing Terraform, right? So the workflow is like, let me try to type it little here. So we do Terraform, sorry, Terraform init, and then we do Terraform Terraform plan. It is, and we do Terraform deploy. So this is a three step and to start with, right? You can have your own things, and then Terraform deploy. So now what happens in init, right? I just did a typo here, so I'm gonna fix it. What happens in Terraform? So basically, as I mentioned, Terraform is kind of if you look at my folder structure, right, it basically is a bunch of tf files. Tf stands for Terraform, and the language is called HashiCorp, something called HCL, HashiCorp code language, right? That's kind of a JSON structured language, as you can see in the code here, right? And what happens with this, when we try to initialize, it basically picks up all the folder things, and then we have variables, we have providers, things like that. And we also going to tell Terraform that whenever we run Terraform, right, what is the place it is going to keep the compiled file. So when I say compiled file, what exactly it means. Now when I write Terraform init, right, Terraform init creates a space, and then because I've defined local, even if you don't define anything, default goes to local. You can have this a Terraform backend as any of the code repositories, any of the storage accounts. For example, you can actually do it like in AWS, you can do it in Azure storage account, just to keep it remote, right? And that's called backend remote. And why we go for remote? Because in today's world, it's not only one person developing the Terraform template, right? It's always people around the globe, and then more than one people, right? So now keeping a remote one makes that you don't keep anything in local, and that also removes the local dependency. Now if I can keep my Terraform template in let's say in an Azure storage account, right? Now if there are five people who are working in a team, we can all refer the same file. And why it is important, and I'm also going to tell you that. So right now, whatever I write here, for example, in this Terraform template, I'm trying to create like Azure log analytics workspace, and then kind of uh, create a resource group out of it. So basically very simple, two resources. All right. Now once I do that, right, because I have pre-compiled it, what happens is I'm going to go to tf state. So now if you look at TF state, right? TF state has, you know, the definition, like what is that I'm going to create and what are the subscripts. So basically the entire details of the code I have written, right? The compiled code. So I'm going to again go back to the main code, and what happens is, even if we want to keep it in remote, so let's say you as a developer first create a resource group, right? And you check in your code, and then you have a remote repository configured, and that goes to Azure storage account. So now in your Azure storage account, you have the resource group created, and you have the TF state file. And TF state file also keeps kind of a trace of what is basically created in Azure or in your cloud environment. Now when the next developer try to write it, so what happens is he picks up that store TF state file, and he just try to add one more resource to that, and try to plan it. So we do init, and next thing is we do plan. Let me see if I can try to get some plan over here. So once I do plan, right, what happens is it's gonna compare with my TF file, right, TF state file, and then figure out what's new. So let's say in the beginning we have 5 servers defined, or maybe 5 resources defined, right? And that is checked in, and then that is kind of stored in TF state file. So now TF state knows that in my cloud environment I have 5 resources created. Now as a second person in the team, right, I'm just want to do some modification in one of them and delete one of them and create new one of them, right? Now what happens in that case, the moment we run Terraform init and Terraform plan, so basically it is going to connect to that TF state file and figure out, based on my last state, right, what are the changes. So it'll figure out I have to delete one resources, I have to modify one resources. And then when we try to do Terraform apply, right, sorry, it was wrong syntax, but it has to be apply, actually, Terraform apply. So Terraform apply will actually do the creation in the cloud environment. So that's the simple workflow. All right. So that's basically, you write it in the Terraform versioning, right? So and once you and there are Azure repositories, I can share it. There are GitHub repositories, you can directly get all the code in there and then try to install and run it. I can tell you, if you start from the beginning, it should not be taking more than 2 to 3 hours to do the basic setup for Terraform, right? If you have a cloud environment getting up, right? And now once you do that, right, now once you do that, if I go to my TF state file, as I shown you, right, it is like it will store all the things, whatever is deployed as a part of this. And that's why it is sensitive. Now think of a scenario with this TF state can be different from production, for QA, and for for test environment as well, and dev environment as well. Now if you really want to do the version control, if we try to think it from an application perspective, right, our environments are different and developers are different. So what could be done is, whenever you're configuring our remote repositories or remote backends, right? So remote backends, whenever you're deploying remote backends, right, then what happens is, in that case, I'd say in the remote backend, we can create 3 separate storage accounts, and on that case, we can try to store all, and try to access control all these things in a different way, right? And that's how it can be access controlled, right? And you can have administrators access to the simple repo, and then the respective people can have actually respective access to make sure that we don't know all the secrets and don't tamper around the state file. So that's why it's important, and that's a part of kind of Terraform core, right? And then once we change, and that's why it is recommended also that whenever you are doing DevOps deployment or infrastructure deployment using Terraform, you should not be it should not be doing any changes outside the Terraform build pipeline. All right. So that's how should be it, right? So that was like basic infrastructure. I'm also going to talk about how you can deploy the code, and how you can manage that. But again, I'll just give it back to the participants. Anybody have any questions? Anybody have any thoughts? Please feel free to share. And in the meantime, I'll try to make it work maybe.
Sure, folks. Do you have any questions, queries? Please do drop it down in the comment section here so that we get a chance to answer that and learn from it. Like, there's nothing that we can't do without learning anything. So we can learn, we can grow. Yeah. So yeah, I think there is a lot of things coming up, and we are also open for the call for the speakers as well. So if you want to be part of a next session as a speaker, we are open for you. You can just reach out to me. You can reach out to me using this email, or else you can reach out to me on LinkedIn, and we can go ahead and learn something new. And we can also learn something new and also teach something new to the people through the Build Piper show. Of course, this is a great platform, so do join us. And any comments, questions, please do drop it in the comment section here.
So I think I'll just wait for the question and let me see if I can show you a remote, basically TF file also. So let me go back to my storage accounts, and I'm just doing it, and then
All right, we have a
so I'm
question.
just trying to spin up as one of the configured repositories I've shown here, right? If you look at, this is my Azure storage account, and this is where I have put together my Terraform state file. All right, so this also can be done. Now once we, and this is the ideal setup we should be practicing as a team as well. All right, so this is one thing which can be done, right? But this also have some specific challenges, right? So in the sense that there are multiple concurrent update can happen to that, and that can actually mismatch things. Now you have to make sure that the version control and lock is enabled. For example, we can, if we talk about AWS, right? AWS offers a facility that you can actually, attach a DynamoDB with kind of Azure, sorry, Amazon cloud environment or Amazon storage environment, to make sure that there's no concurrent update. It just, queued one after another, so everybody gets latest and there's no issue with it. So that was kind of, I would say, that was the kind of thing where we basically did this, trying to deploy a code, and then from our local itself, right? Let me try again
Sir, and
this.
also there's one question which says
Yeah.
how Terraform is different from Terraform.
Okay. So TerraGrant is, again, TerraGrant is basically an add-on and tool that helps you to, helps you to reduce your code. If you have, like, rewritten the code, let's say if I'm building two servers, right? And I have written that two times, right? So, and what happens is, let's say if I'm in Terraform template, I'm trying to deploy the same thing and write the same code 5 times, 6 times, and 7 times. Terraform is kind of an add-on, I would say, which can be helpful for us to reduce that, code repeatability, right? And I got another question. I'm a little experienced in ARM templates, and I'm planning to go for Terraform. Just stick to it only. So how challenging it? Some insights. Okay, so
It's
I
nice.
myself was a, and that's a nice question, and I myself, that resonates to me because I was ARM guy, so I used to always write ARM, and then and let me tell you first benefits. So let's think of a multi-cloud scenario where you have, you know, um, let's say you're developing an application which you might need to host on Azure, but that uses Atlas database as the backend, right? Or maybe something like that, or maybe a database which in AWS, or just famous in AWS. So now Terraform is only platform, I'd say, or one of the best platform where you can combine multiple cloud vendor code into single one. So I would say there is no challenges, just because the good part is, if I look at, if I just try to share my screen again, and if we observe that, right? So Terraform has this built-in keyword, you say resources, and then Azure resource group, right? And that's where Azure resource group comes into play. So that means Terraform understand that it has to create Azure resource group. You don't need to tell anyone. So because you know, now you know ARM, right? You know Azure resource group what it is. Same thing if you go for AWS, you, if you know the AWS terminologies, right, and the keywords, that should be it. So just try to resonate and then try to modify this, and at least try to write one or two kind of deployment template. It should be good to go. But again, the best practices will definitely come over time, right? So that was something I'd say, and then I think it was helpful for you to get started, right? So yeah.
Yeah, in addition to that, is like something
And
like let's think of something which is very new in terms of deployment. Like you want to connect a Redis cluster, or something like
Yeah,
you want to go with the AWS Redshift as a new
yeah,
database. You want to experiment
correct,
with it, and
correct.
provisioning process is seamless here. It's like boom,
Yeah,
you just have it.
boom. You just go. I mean, you don't need to worry about it. Terraform does it for you, right?
Yeah, I think that's the
So
best part about it.
that's the best part. Exactly.
And also, you can
So
also do not have to worry about the misconfigurations that you can get, right? You can configure it accordingly. And if you misconfigure it, just delete off that code, just add a new set of code. Yeah, that's the whole point here. Sure, sir.
yeah,
You can go ahead.
let's try to get me something over here. Let's see. Okay, I think I was just trying to get the demo again. Okay, that's fine. I have some version conflict in my machine, so that's another thing. So this is we all talked about having this, and then you can actually implement GitOps process as well. For example, if there are multiple people in team, right, you always can put all the source codes in GitHub, and then, or maybe whatever code vendor and code repository you prefer, right? It supports quite a few environments and products. So once you do that, right, so as a developer or as a kind of ops guy, we create a pull request, right? And that in that pull request we can actually do some validation, like in that build pipeline itself, right? You can say Terraform init, Terraform plan, Terraform deploy, and then Terraform destroy. So it's going to create and validate your PR, right? And then before it goes to main and merges it. So once it gets merged into main, it actually go to the actual pipeline with CI, or maybe your actual infrastructure. Before that, you can still also can kind of do and modify things in the pipeline, right? So that was something which you can also adopt as a part of process. And you might be hearing all about GitHub Terraform Enterprise, right? So what basically does it gives you an environment where, as an example, I talked about storing your state file, right? So you can have something like workspaces there, and then create your state file and store and manage it in the enterprise cloud. But again, the reason I prefer this kind of cloud vendor storage account, because let's say you have three different environments, right? You can have separate storage account and access control them separately. But in the workspace, right, if you're using same workspace, maybe you might not be able to access control that in the Terraform cloud. But again, that depends on your organization policy. There are different ways to manage it. So that's where I would say, to if you really want to get started, there can be a simple exercise. So if you are coming from, if you're new to the infrastructure as a code, or you're coming from another cloud, for example Azure Resource Manager or ARM, or anything from AWS, right? The best way is just to pick up a small example, pick the resource you like the most in the vendor, and try to deploy the resource using Terraform, and try to use in it, set up a local repository, or set up a local backend in your machine, and then start init, start plan, and start deploy. You should be able to see what exactly it looks like. Yeah. So that was basically, you'd say, kind of a thing you should see in the Terraform world. And there are enormous support from Microsoft, AWS, to Terraform, to make sure that the Terraform templates are updated and versions are updated, right? So try to follow documentation. That's really 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 good to follow through and then understand. And also, obviously, you have always great GitHub repos which has ready-made code if you want to try it. But again, I would suggest, as if you really want to get started, the first should not be a copy from a repo or clone from a repo. Try to set it up on your own, right? Let it go wrong, but try to do it from scratch. And once you understand the process, right, you should be able to say tf state file, tf state backup file, right? Then you will also have an understanding what exactly Terraform works behind the scene. Then you can clone repo, or if you really want to go further, right, you can actually do a build pipeline, right, in your GitHub repo. And public GitHub is always free, and you can do it. So let's say you want to connect to Azure, right? So you can create a remote backend to one of the repositories and on one of the storage account, and then try to go once for all, and then try to deploy your favorite resource. It can be even single resource. You don't need to be like a full complex deployment. And then run it through a build pipeline in Git, right? And then try to deploy to a cloud vendor. So that should be, my opinion, if you really want to get started with Terraform, right? And I think there's another one also. What is about Ansible? What is advisable? Is it advisable cloud? Yeah, I think which was you answered this, right? So yeah, if you really have a machine, let's say, which has Linux, and there are 55, let's say, other five dependencies, right? So if you want to have Ansible works on that place, right? I mean, you can also collaborate with Ansible in Terraform, but it is not an absolute mandate if we talk about infrastructure, because in the way I see it, right, in today's world, if you really want to kind of it all kind of, if you have a server, think about on-prem scenario, you don't have any other option to delete or scrap the server and build a new one. You have to have the dependencies installed, and then there are cases you might face a lot of issues to install something on an existing setup. But in cloud environment, it's rather what you do is you spin up a whole new environment with new dependencies and then put your code there. It's a lot more easier in terms of cloud, right? So
Yeah.
instead of having the dependencies, always try to rebuild. And yeah, that helps a lot. And in that
Just like
way
your
you also,
OVM
yeah,
file in the VMware or somewhere
yeah,
else. You
yeah,
just have that version and you want to make sure that every machine get configured at once and all these dependencies and libraries are already there. I think Ansible is a great tool for that.
yeah, 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 that's right. That's exactly it is.
Sure, I
So
think you can go ahead, sir.
yeah, thank you. So yeah, and the next part is when we do our setup, right? As I talked about, the first setup can be, you can have your own vendor and you can connect and try to do a local deployment from Terraform. You do init, you do plan, and you do kind of apply. And there's one good thing, right, specifically for non-prod environment, because you don't need to keep your non-prod environment up and running, and your cloud bill increasing. So Terraform gives you, for example, if you want to go for ARM and then try to delete all the resources, right, either in for example, you have 50 servers, and then if
I
you've
think you're
configured that
sharing
in
a
a
different
Terraform template,
screen.
all you need to do is Terraform destroy. So Terraform makes sure that all the things whatever was created through TF state file, right, it cleans it up. So the cleanup is also really really neat with this setup. So that's what I'd say. Just try to, and always what we recommend as a part of non-production pipelines, let's say build or test, right, because your code has to be tested in the same environment. So what we should do is we do Terraform init, Terraform plan, Terraform kind of deploy, and then always try to get that you know uh, try to get that thing over here, right? So that should be it. And let me get to that, and I'll just show you this one, right? And as I mentioned, right, when you do, and the good part about init is when you see init, it basically download all the dependencies I've defined and then providers. And also one more important part is to understand the provider. So I think I've just done it. And one more thing worth mentioning, right, on the left side you see there are a couple of files, right? So you can actually absolutely write everything in the single main file, but that's not the right way of further coding. So you can actually have different code files, and you have different variables, right, and which variables can be passed during the deployment, during the build, from a GitHub secrets. If it is sensitive, all those things can be done with a file called tfvar. So I have variables defined, as you can see. This is like by using within the Terraform. So I have variable defined here, and then what I'm trying to do is trying to copy this, and then you see that this is resource group name, right? And I have put some default values, and then if I go to main, you see this is the resource group name, and that's where I'm passing it from the var. And talking about dependencies, right? So if we look at the small snippet, the first thing should happen is create a resource group and then create a log analytics. So we need to make sure that the resource group created gets created first, right? So now what has to be done for that is you create the small snippet and then define it from the variable. And then, because see, this is the name of the resource which I'm creating. So name in the sense, not in your cloud vendor, name within the Terraform environment. Now if I try to search it, and then what I'm saying is Azure rm resource group dot that particular location and name. That means by seeing these two lines, I am making sure that the second snippet always gets executed after the first is created. So that's an internal dependency we can create using Terraform. That's one thing. But again, there might be cases, let's say, there are resources like you have a VM, you have a VNet, or you have storage account, right? Though they are not dependent on each other, because you might not need any input from a storage account while creating a VM. But for your web app or for your application to be hosted, both are important. So there is a command called depends on, which you can specify to make sure that it depends on some other step which has to be created there. So dependency is also available as a part of kind of Terraform deployment, right? Now the next and final starter thing would be, right, how do you basically work as a kind of developer and what should be a developer workflow. All right, so now to tell that, I'd say there's a quick workflow. I'm going to write it here, and then if you want to follow, and again, this is a straightforward one. You write your tf code, right, and then what you do is run it run it locally, which I'm trying to run right now. And then once you do it, let's say you have your GitHub setup, right? You create a pull request, right, and then in the pull request you can run your test basically. So when you say test, you can test it across environment. You can put some testing, um, application testing. So just thinking through the infrastructure as the application lifecycle management, right? So that's where you should go with that. And then what you'd say after we run test, and when I say this front arrow, everything is dependent on one another, on another in the GitHub space or in the entire workflow. So if anything fails, either you get notified or you get an email, or whatever, you get notified, you have to rework from that phase, right? And then we just, and before that, when you create a pull request, I'd say create create CI environment. So in the CI environment, you create the infrastructure you're creating before you're running the test, and then you and destroy them, and then you merge it to main, and then you go to prod. So that's the standard workflow looks like, and would be my recommendation as well, right? So if you really want to get started, this is where you should be getting started around, right? So that was kind of a stuff I would like to say. Okay, so again, I'd like to take a pause here before I would summarize. Any questions?
Sure, I think somebody asked I missed the recording. Don't worry about that.
Yeah,
we still have the recording on our YouTube, LinkedIn, Twitter. You can go there, check us out.
yeah.
Yep. I think if you guys have any questions, do drop it down here so that we get to address at that right point. Like it's going to be tough once we enter the demo mode.
Yeah. And also, I would say maybe Bishwash will share you at the end while it goes to YouTube, right? So you'll definitely get some repository link to get started, and they're really, really well documented, and that's where at least I got started, right? And
Like
it works.
I think I can just share it right now here. I
Yeah,
think this
yeah.
is
And
this is
also,
the tree that we have. Yeah, you guys can go check that out there.
yeah,
So I'll just put it in LinkedIn right now.
all right.
And if you guys have any questions, do drop it down in the comment section in the LinkedIn, YouTube, you name it, it's there. So yes.
I think in that case, just to summarize, right? So Terraform is something which provides your infrastructure as a code, and the best way to get started is If you're application developer, start thinking how a code gets deployed. A developer writes a code, it does some testing, it deploys to a test environment, and then that goes to production, right? The same framework gonna be applicable for the infrastructure as well. I know it's a little difficult to because we have seen servers from the beginning, right? Servers are like hard coded machines, and application is software. But you have to have that mindset that indeed today's world infrastructure is a code. A server or an application both works on a code, and then Terraform is one of the best platform to do that because it supports multi-cloud environment with the providers it has, right? And it's really up to date, right? Now try to get set up. Maybe if you're using VS Code, or VS Code is the, I would say, because I use it, and then it's really free. And then and the good part is the entire demo and everything whatever you're seeing, right? You can almost do everything for free. I mean, you don't need to have a big subscription and things like that to. Oh yeah. And I think there's one question, may I know totally from scratch? Yes. So if you really want to start from scratch, right, fundamentally what you should be doing, if you're versed with some of the cloud environment, that's great. If not, try to choose one of the cloud environment which you like it maybe, and then try to choose a resource which you understand or what you work. Maybe it can be a storage service, it can be a server, it can be an application, anything, right, which you understand what it is in detail, and then try to templatize them by doing a local storage and deploying it into the cloud environment, right? Yeah. And any question, guys, on Terraform, as Vishwa said, you can reach out to Vishwas and me on LinkedIn. We are happy to help you out on the setup or any issue you face with, right? So I think with that, I think that was a quick starter I had on kind of Terraform. Until you have any questions?
Yep, I think there is a lot of issues when it comes to versioning as well. So you also need to be very very careful with respect to versioning.
Yeah,
I think, do you have any
yeah.
demos right now, or else
I think I
you have
don't
some
have
demos?
much, but no, I don't think I have a versioning one. Let me see. I can talk about not on Terraform, but okay. Let's see. Let me see if I can show you one. Nope, I don't see anything handy. But again, from a versioning standpoint, the solution is GitHub. So if you start using GitHub, that's the best place. You can version your all the code and things like that. So should be fine.
Sure. I think
Yeah,
thank you so much, folks. Thank you so much for tuning in. And you know, on a Sunday morning where you're enjoying
no
your
problem.
tea or an idli on the right side or whatever it is, you're just seeing us, and it gives us an immense motivation to even just do something more. Of course, next month it's all about Elastic. Elastic is going to be there, and it's not a problem. We just have a little bit more of an intro for the Terraform. I think there is a lot of
Yeah,
speakers coming out
yeah,
with respect to the Terraform as well.
yeah. And I think you got one. Can I get a little summary of what are the different files there in Terraform and their role? Obviously, yes. So I think which was you can. I think yeah. So basically, you can see, right. This is one.tf file, and then this is on variable.tf, right. So compared to ARM template, you can the way we specify parameter, right. So this is kind of a parameter file, I would say, right, which helps you to take the input from the user. So in a variable file, and also you can have something like tf-var files, right. And then just compare Terraform, right? In one JSON, you can deploy all your codes, or you can actually create multiple file to refer in between one to another, right? And then in Azure ARMS, same thing. You can have multiple TF files to have the responsibilities. For example, if I have TF state, TF provider, I can have all my providers in one file. I can have something like variables in one file. Similar to that, I can create like log analytics or any other resources which I am defining for one file, so it can be separated. And when you see Terraform plan, right, it basically compiles all the things whatever is referenced in the folder. So there's nothing that you have to specifically specify in main is just kind of more of a named container, right, which can hold all your source code. But apart from that, you can have multiple file. Now once you the only difference in Azure what happens is, in Azure when you try to run the command, right, it basically submits that to Azure as a deployment without even without even kind of do things like that. So in there you always have a plan file, and then that plan goes and deploys. So is there a way, there's one more, is there a way to add things Terraform which are created manually? So again, that's not a good idea or best practice, I would say, right? But you can give it a try. That there is a command called Terraform Refresh, right? You can give it a try to do that command. That should ideally solve a problem to some extent. Basically that will refresh all the tf state file based on the configuration you have, and then you should be able to good to go. Yeah.
Yep. I think, yeah, it's a great start.
Dependencies. Yeah.
Please share the GitHub repo and the link. Yeah, it's here. You guys can go check that out on LinkedIn. And if you are on YouTube, it's still there in the comment section down there. Is there a way to add things in Terraform which are created manually? Yeah,
Yeah,
this is the
I
first.
think I just did answer that, because that's not a good practice, because if you're using Terraform, you're ideally supposed to do all the things to make sure that you don't break things. But so one of the ways you can define all the things manually in the main file or in the respective tf file, and try to run a kind of Terraform refresh, right? That should help us.
Sure, I think probably we might end up with one more session on Terraform with Samik
Yeah.
sir because we needed more of an
Yeah.
hands-on with respect to that. I think
Yeah, guys.
next session is going to be an hands-on session, so we'll
Yeah.
go ahead with that, folks. So yeah,
Yes.
sure, folks, we can get the things done. We can get this thing sorted, and also a lot and lot of demos are coming up. So stay
Yep.
tuned for that. Many people, Elastic, there's a lot of sessions planned. So this is Vishwas Nayan signing off from this session, and thank you so much, Samik, for being on the show. Means a lot. And bye, folks.